This video will cover the topic, finding the average rate of change of a function given its graph. We may recall that a graph of a line has a constant slope throughout, and to find the slope, we could use the slope formula. M equals f of x2 minus f of x1 divided by x2 minus x1. And remember that f of x2 and f of x1 are y values. We would use 2 points on the graph to do this. The slope is also called the rate of change, because it represents the rate at which y is changing as x changes.
What is an average rate of change then?
In graphs that are not lines, such as a parabola, there is not a constant slope or rate of change. In fact, the rate of change is always changing in such graphs. So when we use the slope formula to find a slope between 2 points, we are finding an average rate of change. Let's work on an example. The graph of a function g is shown below. Use the graph of the function to find its average rate of change from x equals 3 to x equals 4. Simplify your answer as much as possible. So we need to find the average rate of change between x equals 3 and x equals 4. So the points 3, negative 4 and 4, negative 1. We can see that between these 2 points, there is not a line, but there is a curve. The slope is constantly changing. Using the average rate of change formula, we will essentially find the slope of a line drawn between these 2 points. Do you think you can try that out?
Sure. For the formula, I would substitute in -1 for f of x2, -4 for f of x1, 4 for x2, and 3 for x1, written as -1 minus -4 divided by 4 minus 3.
Good. Now it needs to be simplified. I think you can handle that.
I think so too. In the numerator, the two negatives make +4, so -1 plus 4 is 3. 4 minus 3 in the denominator is 1. 3 divided by 1 equals 3, so the average rate of change is 3.
Great job.
Just to summarize, in order to find the average rate of change between 2 points, I use the same formula as the slope formula by finding the difference of the y values divided by the difference of the x values.
Perfect understanding.